In this, the final part of our series on making a small programming language, we will write an interpreter. And an interpreter is what takes the past expressions that we have here and evaluates them. And what that means is, for example, if we print something, the interpreter will print it out. If we have something like 2 times 3, it will calculate that. And finally, when we have an assignment, it will assign that to the current environment. So we need some way to represent the environment, and it's quite a simple language. There's only a single global scope, so we can just use a hash map. And I will make this type alias, which is an alias for the environment, and it's going to be an alias from the name to the value, which in our case is just integers. So once we have that, then we can write the type for the interpret function, which will take some, not some tokens, but some expressions. And they now live in their own file. It will take some expressions, and it will take an environment, which we'll put as a mutable reference to an environment. And we can also make this a reference. The environment should be a reference because we might want to interpret multiple times using the same environment, so we don't want to take ownership of it. And perhaps we also want to evaluate the expressions multiple times. In any case, let's get started. An interpret function will basically just loop over the expressions, and it will evaluate them using the environment. The evaluate function takes a single expression, which I guess will be a reference to an expression. It will take the environment, and it will produce a value. When you evaluate an expression, it always produces a value. That's the distinction between expressions they yield values, and statements don't. In our language, everything is an expression, so everything will give a value. So let's match on the type of the expression. And for example, if we have a number, it has a number implementation, and that number implementation has a value, and it has something we don't care about. Because when you evaluate a number, it should just return the value of that number. Now, let's actually open up our expressions over here. So we started with the number because it's the simplest. But let's now take the binary operation. So again, we need to get this binary operation implementation type. So it has a left-hand side, it has an operation, and it has a right-hand side. Actually, let me close that because it's a bit annoying. And this one is a bit more interesting. So first, we need to evaluate the right-hand side. Then we should evaluate the right-hand side. And then depending on what the operation is, it's a token, we can just switch on the token type. So if it is a plus, and now let's actually import those. Just import all of them. If it's a plus, we will return left-hand side value plus right-hand side value. And I think you can guess what will happen if it's a minus. And let's just copy it a couple of times. And if it's anything else, we will panic and we'll say invalid binary operation. And we'll just print it so we can see what happens. So there you can see the binary operation is a little bit more interesting. So what's the error here? It's a reference, we need to dereference it. And here we also have to borrow it. All right, let's go on with the next one. For example, the assignment. And assignment has a target and it has a right-hand side. Forgot what we called it here. It's just called a value. So when you assign something, of course you have to let me actually call it, well, we can just shadow. So first you have to evaluate the value, and then you have to insert into the environment at the target, which has a name, which has a lexeme. You have to insert that value. And remember when I said that everything is an expression in this language, which means that everything returns a value? So what is the value of an assignment? What is the value of a equals 2? And what will be most convenient is if we say that this has value 2. Because then we can write things like a equals b equals 2, and that will evaluate like this. First we'll evaluate this, it will assign 2 to b, and then we can effectively replace this with 2, and that will assign 2 to a, and then we just have 2 left. The final 2 we don't really do anything with, but the first 2 was quite useful because it allowed us to write a equals b equals 2, which you might see in a mathematical expression. All right. Let's see what it complains about here. We need to return something. So let's do that. Let's return the value. And this one we have to clone. And that's an assignment. Now let's then take a variable, which variable implementation, and I think it just has a name. So what we need to do is we need to look up the name in the environment. However, that can fail. So we'll say here, let's get the name, lexeme, and if it's successful, so if it is a sum, and I guess we need to put a reference here. If it's a sum, we'll do something. If the variable doesn't exist, it's actually an error, so we'll say variable this thing isn't defined, and what we'll put here is the lexeme. If it does exist, we'll just return that value, and we need to dereference. Now we have variable, we have assignment, we have binary, we have number, we also have function call. So this one is a little bit interesting. Let me remind myself what the arguments are, or the data is for this type. So it's a name and an argument. Now, we don't allow user-defined functions, and we only have one built-in function. So that means if the name is equal to print, then we're happy. But otherwise, we actually want to to say undefined function like that. If it is print, then we want to evaluate the argument, and then we want to print that to standard out. Just print the value, and then again, remember, everything is an expression, everything returns a value. So what should we return here? Well, you could maybe argue that we should return 0, or we should return -1 or something, but that's going to lead to weird cases. The most natural thing is to return just value. And that's a bit unfortunate. That is called name, but whatever. So that actually finishes the interpreter. Let's move things around a little bit. So it's alphabetical. Let's put that there. Put this guy up here. And this guy here. Now I think it's alphabetical, if I'm not mistaken. Now let's see what happens. So we have some expressions, and let's interpret them. So let me go in here and say cargo run, but actually there's some complaint here. It takes two environments, so of course it takes two variables, so of course we have to make an environment, and that will just be, let's do it like this, and we will give that here, and this one should be a reference as well. For some reason we said we wanted that. Let's try to run it. So it prints a lot of stuff. Let's remove that, and let's clear here, run it again, and run it again. So we see a 6, and the 6 comes from this print statement. And we can actually make this a little bit nicer, I guess. Let's try to do something like this, where, well, no, we cannot do that because we would need to have a string representation of every type of expression. So I'm not going to do that. But now we can do some very difficult calculation, let's say this, and we can actually just see what the result of that is. We can also do some other cool things with our little language. We can say that actually, let me assign both B. Well, let's see what happens if there's an error. So it will just panic. But, well, okay, that panicked somewhere else, like this. It should say variable A123 is not defined. Okay. You can see it's still equal to 6. Then we can say C is equal to print B plus 3. And then we can say C divided by A, something like that. So there you have it. Now we have a small working language that has basically all the moving parts that a real fully fledged language would have. And it is very bare bones. Things like error handling is not done very well. We just panic if there's an error everywhere in the code. We just panic. And things like nice error messages and all of that is not very well supported. Now beyond that, it's also a simple language. We only have numbers as values. Everything evaluates to integers. So that's an exercise you can try to do for yourself. Try to convert this into something that has also floating point numbers, or maybe integers and strings and all these sorts of nice things. That's it for now. I hope it was interesting, and let me know if you want to see something specific. And I will see you in the next one.